Saxon's Calculus Lesson 65 is about more integration by guessing. So there are 8 examples in this lesson. Yes. So we're just going to chunk our way through them. So the first one is the integration of the sine of 3t. So how did we get sine? Well, it came from negative cosine. How did I know it was negative? Because cosine gives us a negative. So if I don't negate it, then I can't get it back to being a positive. So negative cosine of 3t. And remember that we have to derive every part, so that puts another 3 with this problem. But my original did not have a 3 in front of it. So I need to get rid of it to fix it. So that means I need, so this is in front with the negative. So we're going to make it negative 1/3. That will undo the 3. And then our cosine of 3t. And because it's integration, we always plus c. And then mentally, if you check that, this cosine goes to sine of the 3t. And when you derive you get the 3 multiplying, or the negative 3 multiplying with your negative 1/3, which takes it to positive 1. All right, example 2. Integrate x squared 3x cubed plus 4 to the 4th power dx. So we are going to isolate our 3x cubed plus 4. And what happens if we derive that? So that would give us 9x squared. The 4 drops off, and I don't see the 9. I see the x squared, but not the 9 in my original. So that tells me I need to be putting a 1/9 with my original. However, our 3x cubed plus 4 had a 5 with it, because that would make it u to the 5th. So that would give us 5u to the 4th, which is where my u to the 4th comes from. But the 5 is out here messing with me as well. So I have to remove the 5 by also flipping it. So that makes this denominator 9 times 5 is 45. So 1/45 with my 3x cubed plus 4 to the 5th power was my original guess, and then the plus c. So you see the adjustments that you're having to make based on the whole numbers here. Example 3. Integrate x squared with the dx over top of the square root of x cubed plus 1. All right, I feel like I should be fixing this to one line. So that's going to be x squared multiplying with x cubed plus 1 to the 1/2, because negative 1/2, because it's in the bottom. Now, testing that would mean negative 1/2 x cubed plus 1 to the positive 1/2. And deriving the x cubed would give me 3x squared. So there's my x squared, but this 3 technically is coming over here. So negative 3/2 I don't want. So I need to get rid of it by flipping it. So 2/3 will take care of it, but it needs to be negative 2/3. Because I created a negative, I need to undo the negative. And there's the x squared. So the original was then x cubed plus 1 to the 1/2 plus c. Double checking that. Oh, sign difference here. Just a second. Why do they have that as a positive 2/3? If I put this down here, does it take care of itself? It does take care of itself. So what I did to test it was I actually did the deriving here, which took me to a half, multiplying with the 2/3 that was there, changed the exponent to -1/2, derived here and got this part. All of the numbers canceled off as we set this to do, and then that left us with x squared, and then this negative meant it went underneath. So yes, it is supposed to be positive. So even though I have the negative here, I don't want it in the original, because otherwise then I'm inserting a negative that I don't want into the problem. All right, example 4. Integrate cosine cubed of 2t sine of t dt. So because the cosine has the cubed and the 2 with it, I'm going to start with that. So cosine goes to negative sine of 2t, and then the 2 from the 2t, and that means I have an extra 2 in there that I don't want, so I need to remove it with a half. And the cosine gives me the sine. I feel like I'm losing a part of this one though. Oh, yes, the cubed. All right, so then that would have been u, so to the fourth, because I need to get it down to cubed after I derive it. So then I'm inserting a 4 into the problem that I need to get rid of. So 4 and 2 makes the 8th. All right, so negative and my 8th, sine to the 4th of 2t plus c. Now because that would put the 4, that would lose the 2, which would also eliminate it, taking me down to the cubed and the extra. So negative, let me see if that's what they have. Yes, yes, yes. Okay. Example. Oh, that was 4. 5. Okay. Integrate 4 secant squared 3t dt. Okay. So my secant squared needs to come from tangent. So tangent squared 3t. I wrote that so badly I was having trouble reading it. All right. Then knew that didn't sound right. Tangent squared does not give me secant squared. Tangent gives me secant squared. That is the memorized formula. Yikes. So tangent of 3t then gives me the 3 here extra, which I don't want, which means I need to make it the 1/3. However, the 4 is there, so I need to multiply it to put it into the problem. I'm not undoing it, I need it. That's why it's staying. So 4/3 tangent of 3t plus c. So the new thing there was that coefficient. Example 6, integrate e to the square root of x over square root of x dx. Now they wrote it in the numerator, but same thing. So we first need to fix this into one line. So e to the square root of x with x to the negative 1/2. To match this format, I'm going to change this to x to the 1/2 rather than in a root. So I believe that my core should be the e one. And since e remains the same, e to the x to the 1/2, but the derivative of that gives me 1/2. So then I need to put a 2 in front to remove the 1/2. So e to the x to the 1/2, 2e to the x to the 1/2 plus c. But let me double check something because I assumed, and I didn't check it, this part. So it came from this x, I didn't write the half, then it came from x to the 1/2, which would give me the, yes, when I work it backwards, the x to the negative 1/2, which goes underneath. Yes, it all checks out. Example 7. Integrate 2x cubed plus x over x to the 4th plus x squared with the dx. Now, I feel like a natural log because I've got it in a fraction, and this looks like the main part, and this looks like it's a piece of the deriving. So if I assume it's natural log of x to the 4th plus x squared, then that would give me this part 1 over, and then deriving here would give me 4x cubed plus 2x. And I have a 2x cubed, not a 4. So I need to take half to accomplish that. So a half needs to go in front of this statement to fix the 4 and the 2. They both needed to be divided by 2 to get to the 2 and the 1. And then I think it should just be my add c. A half natural log this stuff plus c. And finally, example 8, which is the integration of cosine of ax dx over the square root of b plus sine ax. All right, the messiness is definitely the bottom. So I need to first write it all in one upper column. So we've got our cosine of ax with our b plus sine of ax all to the negative 1/2. So that's going to make it 1/2 with b plus sine of ax to the positive 1/2. 1/2, and then the derivative of b is a constant dropping off. The derivative of sine goes to cosine of ax, which we had. So what I don't want is the 1/2. So I'm going to flip that to 2. but the derivative of ax is a, because remember I have to derive every single part, and I don't want that a, so it's got to be in the dividing out. Now my original was b plus sine of ax to the 1/2 plus c. Ooh, the more complicated they make them, the trickier they become.